Okay, question 3. We're given a graph and we're asked some questions about that graph. Now the graph is of the function f of x, and the questions are about the derivative of the function f prime of x. Note that we're not given the actual algebraic form of f of x. We're just giving its graphical representation. So if we don't have f of x in algebraic form, how can we say anything about f prime? Recall, if f of x is increasing, then f prime of x is positive. And if f of x is decreasing, then f prime of x is negative. We need to use this logic, or this definition of increasing and decreasing in terms of the sign of the derivative, to answer the questions that are here. Part A says if f prime of x is equal to negative 1/3 at one of the points indicated, at which point must it be? So looking at this curve, we see it's increasing. The y value is increasing as we move to the right at x is equal to m. It's increasing more quickly at p. And it's decreasing at x is equal to a. The y value is going down as we move to the right. So the question, part A, says if f prime of x is equal to negative 1/3, at which point must this be? Well, the fact that this is negative derivative means decreasing function. So the coordinate must be a comma b. The only labeled coordinate that's negative. Okay, part B asks if f prime of m is smaller or larger than f prime of p. Explain why. Well, f of x is increasing more rapidly or more quickly at x is equal to p. So what I use, I use mentally to think about rates of increase or rates of decrease, is I imagine what the tangent line would look like at each of these two locations, and I compare their slopes. And the slope of the tangent line at p is much higher than the slope of the tangent line at m. So the function is increasing more quickly there. So f of x is increasing more quickly at x is equal to p. Thus, f prime at p is larger than f prime of m. And the explanation is f of x is increasing more quickly at x is equal to p. So I answered it kind of backwards. Okay, and then part C, at which point does it appear that f prime of x is equal to 0? F prime of x equals 0 means the tangent line has a slope of 0. So I think what the tangent line looks like at these points, I'll draw the tangent line at the negative point, draw the tangent line at this point over here, C comma D. So it has to be at C comma D. It has to be at what looks like the minimum of the function. So tangent line is horizontal, slope equals 0 at x equals c, thus point is c comma d. Okay, that's it for this question.